Oh, hello. All right, so this is part 2. This is getting the formula from the name of an ionic compound. We said ionic compounds are generally between positively charged ions, which are usually metals, and negatively charged ions, which are usually nonmetals. Okay, so we also said that the families on the periodic table, when metals bond with nonmetals and when nonmetals bond with metals, the charges that they tend to gain are +1 for group 1, +2, +3, +4, -1, blah, 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 into our beautiful song 1, 2, 3, 4, 3, 2, 1. Okay, so the things that you need to remember are that all ionic compounds are neutrally charged. Okay, so think about that if you have salt, that it doesn't have a net electric charge, which means that the amount of positive ions the amount of positive charge is equivalent to the amount of negative charge on it. So let's go from there. Those are our 2 rules for it. Okay, so potassium iodide. All right, well, let's look at that. All right, we got potassium, we got iodine. But now, here's the other thing. We need to also make sure that the charges are balanced. Okay, so what charge does potassium have? It has a +1 charge. What charge does the iodide part of that have? It tends to gain a -1 charge. See here? Zoop, zoop. All right, so is this balanced? Yes. So the way that you would write that is Ki, okay? That the charges are balanced there. Now let's take a look at a different example. Calcium, okay, now what, and chlorine, okay, now what charge does calcium tend to gain when it's in an ionic compound? +2. How did you know that, Mr. Gorin? Because it's right there. It's in group 2, which tends to gain a +2 charge. What about the chloride part? It tends to gain a -1 charge. Uh-oh. What's happening here? If this were the formula, that is CaCl, what would the charge on that be? Well, since this has a +2 charge and this has a -1 charge, then that would have a net positive charge. We know that that's not true, okay? So what does that mean? How could we make this so that it is balanced in terms of charges? Well, if we had 2 chloride ions, what would the charge that the total chloride ions is contributing? It would be -2 because it's 2 of the -1 charges. And how many calcium ions would be contributing? It would be 1 of that would offset the 2 negative charges. So that is the formula for calcium chloride. Make sense? Want to try another one? Yes. Okay. Sodium oxide. Okay, so we got sodium. What kind of charge does that gain in an ionic compound? +1. Oxygen tends to gain -2. Look. All right, so now, how many sodium ions is this neutrally charged as written if it were NaO? The answer is no. It would have a net negative charge. So we would need 2 sodium ions for every 1 oxygen ion. Now, what would the 2 sodium ions be contributing? They would be contributing a +2 charge. The 1 oxygen ion would be contributing a -2 charge. That would give it a net neutral charge. So Na2O is the formula for that. All right, let's look at one more that might be a little bit strange. And you might be noticing a pattern that you can kind of switch these numbers sometimes. Sometimes that works. Sometimes it does not. Okay? So for example, magnesium oxide, what would the charge on the magnesium be? +2, oxygen -2. You do not write Mg2O2 because it's already balanced as is. Make sense? Okay, please ask if not. One other one that we may want to do, let's do magnesium phosphide. All right, we got magnesium has a charge of +2. Phosphorus, that phosphide ion, has a charge of -3. How the heck do we balance that? Well, you can always try the sort of switchy things. That is, if there were 3 magnesium ions, what would the charge that it would be contributing? It'd be +6. Now, how many phosphorus ions do we need to offset that? We would need 2. This is the formula for magnesium phosphide. Yay.